All right. Hi there. I'm Diane Kimsey, and we are here today for part 4 of Eureka Math. We're going to talk about today number bonds and tape diagrams. I'm Diane Kimsey, and I am your consulting math teacher for grades pre-K through 5th grade. I'm really excited to share with you today about number bonds and tape diagrams. So let's get started. I'm going to bring up the whiteboard feature on Zoom. Okay, so today's class is going to be taught on here, and trust me, if you have me come out to your classroom, I write a whole lot better in real life than I do on here. So just trust me on that. All right, we're going to get started, and one of the things I want to point out to you is that when you do write on your Promethean board or on your whiteboard, please use different colors. It helps kids to see the different parts of the math problem, okay? It helps your EL children. It helps them focus the route that you're taking. They're having to process this math in a different language. It helps your children that are a little bit slower in in their auditory skills, okay? So please change your colors. It really does help so many ways, so many children, and even those who are, learning right as they should, if they need to look up at the board later to help them get through the math that they're doing on their own in the problem set, they can look up there in the different colors and be able to track where they're at. Okay? All right, so enough on that. Let's go ahead and get started. We're going to work with number bonds, and these are things that we start at the kindergarten level with the kids. And so perhaps we have pink stars, and we have, I'm going to just change the color, and we have an orange triangle, okay? And so at this moment, we're working with kindergarten, and we're working at just identifying what do we have here. Okay, and so I'm going to create a number bond, and I would say to my kindergarten class, I would say, I'm going to make a number bond now and help me see what is up here. And so I'm going to put that number bond respectfully below here. And I'm going to come on down, and I'm going to talk to the kids. What do you see here? And have them help me see, I see some pink. I don't know if they're pink or lavender. I'm going to go with the pink, okay? I see pink stars. So it goes star, star. Excellent. What else do you see? I see a red or orange triangle. Excellent, excellent. What do you see all together? Well, I see that red triangle, since I have the red marker up, okay? And I see star, star, 2 pink stars. What did you say you see? I said I see 2 pink stars. Oh my goodness. And so now we're going to take it to the next level. This is what we call the representational level. Now we're going to take it to the abstract level. And the abstract level, I'm going to put in numbers. Now again, back to the color thing. I like to use the colors that correlate with the shapes. And so that way, in case somebody is still learning how to count or apply a number to shapes, this is going to help them, all right? And so stars, gosh, how many stars do we see? I see 1, 2. I see 2 stars, okay? I see 2 stars. How many triangles do you see there? I see 1 triangle, just 1. Very good, I see 1 triangle. How many do we see in all? Now I'm going to change to the same color as my number bonds, okay? How many do you see in all? I see 1, 2, 3. I see 3 in all. In kindergarten, we do what's called counting all. I'm not going to start counting up yet. We're doing counting all. They work during the first semester, so from August until we go on Christmas break. They work on numbers from 0 to 10. After Christmas break, we're going to crank it on up, and we're going to take it all the way to 20 by May, and perhaps even higher. All right, and so we're counting all. All right, excellent job. And so that's kindergarten. Now, one of the things you might notice with the number bonds is I'm changing the direction that the number bond is going. But what we always have is where two numbers attached to one. Two numbers are attached to one to represent the part, and the whole. Okay, part, whole. Now, can we have three? Absolutely, but I'm not going to introduce that until we feel really, really secure in understanding two parts. But you bet we can have more than two parts. Now, what is important with the number bonds is that we, kind of make it a game and say, all right, pay attention. Where did I put the whole this time? All right, pay attention. Where did I put the whole this time? That whole needs to go in different places. And the reason that we're putting, and these always remind me of cherries, the game Hi-Ho Cheerio, these always remind me of the cherries. The reason that we change the direction around, we kind of make it a game with them at kindergarten and first grade, where did I put the whole at, is that we want the kids to become what we call a flexible learner. And the reason for these, so let's do it this way now. I'm just going to give you a math problem. Let's say it's 2 plus 3. Now, we are typically used to seeing the equal sign on the right and the what is the sum on the right. And then boom, we throw in math problems where we put the sum on the left for 2 plus 3. And oh my gosh, we lose half of our class. All right, they're used to seeing it going one direction. We can also, of course, write it going vertically. And then we can write the fact family. And that totally changes the math for so many kids. They understood 2 plus 3, but what are you talking about with 3 plus 2? And so by doing the number bonds, by changing them around in different directions, we're putting that whole, we're putting the answer in different places and making kind of a game out of it. And so when the children do see math written in this way, it's not going to flip them out as much as it used to. All right, and so we're trying to create what we call a flexible learner. All right, I'm going to go ahead and clear that. All right, and so in kindergarten, we're counting all. In first grade, we're counting on. If you have paper and pencil with you, what I would like for you to do right now is to create for me a number bond. And I want you to have fun with it going a different direction. And our number that we're going to work on right now is 7. Now, what I always ask for kids to do, and I highly recommend that you do this as well, is have the kids create 2 math problems, at least 2. And I'm going to have my number bonds going 2 different directions. Okie doke? And so the kids are going to put 7 in the whole. 7 represents the whole amount, W-H-O-L-E, not a hole in my shirt, whole meaning the whole thing. And we need to explain that to the children as well. They need to know that those are 2 totally different words. All right, so we have 7 all together. What could be my parts? And the reason why I always have kids come up with 2 answers, if I called on Joey over here and said, Joey, what did you get as an answer? And Joey says, I got 6 and 1. Excellent job, Joey. And now I turn over here to Laura and I say, Laura, what did you get? I got the same thing. All right, and so Laura can actually look and see, oh, wait a minute, I got 5 and 2. Excellent, Laura. And now we can turn to somebody else. Alexander, what did you get? And so Alexander, he's going to say, I got 3 and 4. That is fantastic, Alexander. All right, so I'm going to get one here for Alexander. He got 3 and 4. All right, and now I could go to Jamal. Jamal, what did you get? Well, they're all there, Mrs. Kimsey. See, there's 1. Let me change my color here. There's 1, 2, 3, 4, 5, and 6. Jamal, there's 1 more, buddy. Let's see if you can figure out 1 more. There is 1 more there. And Jamal, I'm going to give you $50 million if you can discover it. Of course, everybody now is going to go, oh, I got it. All right. So Jamal, I want a math problem that equals 7 that we don't see up here. And then I might give a hint, because even adults are like, say what? There's 1 more? Yes, there is. 7 plus, oh yeah. 0 equals 7. And as I'm reading these, I'm going to throw in that plus sign. I'm going to say the word plus. And we can even crank it up and say, okay, so 5 plus 2 equals 7. Excellent job. And then we can ask the kids, how many of you got 5 plus 2 equals 7 on your board? All right, and you can just do a little survey of the land. And so, again, at kindergarten, we're counting all. At first grade, we're counting on. Now, something that we haven't stressed right here is that we are teaching the kids actually math facts. These are all the math facts that are out there for 7, but we didn't talk about math facts. We're making number bonds, and it's a wonderful way of teaching the kids math facts without the stress of, memorizing with flashcards. And so this is a great way for them to see it. Now, I would probably be using a type of manipulative, and so you could definitely use this. And so since we were talking about 7, I'm going to take this apart here for just a second. Since we were talking about 7, I would do this with my kids. We have 5 plus 2 more, plus 2 more equals 7. Now, what are different ways that you could do this? So just hang on to those 7. What are different ways that you could do this? Well, here we go. Well, what did you get? I got 3 yellows plus 4 reds. And so using a 10 frame is a wonderful way to teach kids number bonds, excuse me, and to be teaching them math facts without having to memorize them. They're manipulating them, they're touching them, they're creating representations before they make the abstract. All right, it's a very comfortable way for the kids. Now comes towards the end of first grade, the beginning of second grade, and we started talking to kids about making an easier problem. So what if I gave to my class, what if I gave them, let's say 9 plus 5. And we asked the kids, I need you to help me figure out, we're going to turn this into a number bond, 9 plus 5. And we need to make an easier problem. Now the kids have been working with 10 frame, all right? And if I had all of them in here, hold on a second. There we go. So we've got them all in here. And so now the kids are used to making 10. 10 is their comfortable number. 10 is their easy number. And so we're looking here at 9 plus 5. And there are 2 ways that we can turn this into an easy problem. I think the easier way to do it is to take the 9 and turn the 9 into a 10. So I could come over here and say, well, if I did that, that means 9 is just 1 away from 10. And so now 9 plus 1, there's the 10. I'm going to go ahead and drop down that 4. So 9 plus 5 equals 14. And after we do several of these math problems, the kids are going to start with the mental math of being able to see how 9 plus 5 equals 14. You probably won't have to do very many of these, but it's a way that we practice and we teach the kids. How about if we do 8 plus 3? And so what would you suggest that we do? Well, I would recommend that we turn the 8 into a 10. And so again, the kids are used to using the 10 frame. They know if I'm going to turn that 8 into a 10, I need to add 2 more to it. And so if I'm going to do 2 more to it, add 2 more to it, 8 plus 2 is 10, plus that 1, this equals 11. And so they get to the point where they can actually skip writing this next math problem. They can do the mental math and they can start seeing it. They can start seeing the part, whole. I hope that makes sense to you. Let's take a look at, let's do another one. Oh, you know, I was going to say to you with the 9 plus 5, there are of course 2 ways of doing that. And I didn't show you the second way, I apologize. Every kid loves the math problem that 5 plus 5 equals 10. And so we could, of course, turn this into 4 and 5. And there's my 5 plus 5 is 10, and add on that 4 to get to my 14. So there are 2 ways of doing it. But the way that we would really like to express to the kids is to look at the larger of the 2 numbers and turn the larger of the 2 numbers into that 10. And so that is called making an easier problem. And we really start doing that towards the end of first grade. And we really stress it in second grade. So let's do this. Let's do 28 plus 6. 28 plus 6. And so the kids have gotten really pretty darn used to moving on to these larger numbers, and they're kind of excited about it. You have the number line going around the perimeter of your classroom. Hopefully you have something with a number line that's on the children's desks. And so you're going to say to the kids, okay, so which one's larger? 28, very, very good. So everybody knows that 28 is larger, right? All right, so 28, if we're counting by tens, that is in between 20 and 30. You're right, it's in between 20 and 30. And so we want 28 to become which number? 28 or 30? 30, you're right. And so I would take my eraser and I'd erase that. So we're wanting 28 to become 30. All right, so that is our goal. Well, what do we need to add on to 28 to make 30? We need to add on 2. Very good. Let me get it. Whoops, I am so sorry. Apparently, I am on the eraser tool, so I apologize. All right, there we go. All right, so 28, and to take it up to 30, I need to add on 2. So I'm going to come over here to my 6, and I know that if I were to make a number bond with 6, that 2 and then 4 more makes 6. So 28 and 2 more makes 30, plus the 4, and that of course equals 34. And again, many of our children are getting to the point where they don't need to put that whole math problem at the bottom. All right, so they can look at that 28 plus 2 more and say that's 30 plus 4, that equals 34. And so we're really trying to help the children with the mental math, and especially when we get to these larger numbers. All right, so let's do another one. This time we're going to do 36. We're going to do 2-digit plus 2-digit. Again, we're at second grade at this time, so 36 plus 24. Again, our rule of thumb here is to look at the larger number. Look at the larger one. And so the kids all know, oh, that's 36. You're absolutely right. And so 36 sits in between 30 and 40. And of course, we want to boost it up to 40. All right, kids, how many steps is 36 away from 40? 4. It's just 4 steps. That's right. And so we're going to number bond out 24, 4, and 20. And they see that this is 40, and then plus that 20. Oh ho, it equals 60. You're right, you're right. And so again, we're trying to make sense out of it, make them an easier math problem before I ever teach the regrouping, all right? So 36 plus 24, before I ever teach that regrouping. Now I can move this direction and teach it in the regrouping manner. Okie doke. Now I can teach it. So when my kids feel very comfortable over here, they're going to say, well, 4 plus 6 equals 10. What was it that we did right here? We tried to make a more comfortable number. We tried to make it easier. We tried to move it up to the next 10. And so, of course, 6 plus 4 is 10. We tried to find that next 10 to make it easier. And 3 plus 1, that equals what? That's right. It's a 4, it is actually 40. And we added a 2 to it. No, we actually added 20 to it, right? Because it's in the tens place value. And slowly but surely, the kids are going to start understanding that more. I highly recommend that you have both of them on here before you teach. You have the number bond on here before you teach the vertical method, okay? The traditional algorithm method. All right. Let's move up to third grade and see how number bonds are used in third grade. In third grade, we start talking about conversions. And conversions, oh my goodness, they drive us crazy, but we have to teach them. Kids have to understand it. And so we're going to go with 25 minutes plus, excuse me, 45 minutes. Now, I want my answer to be not just in minutes, I want my answer to be in hours and minutes. And so I want my answer in hours and minutes. Before I'd go any further, I'd say to the kids, all right, guys, you've got to remind me of something. How many minutes are in an hour? And so many of the kids are going to say 100. And so that's why you must review this. And so how many minutes are in an hour? Well, there are 60 minutes. And I would put it up here because I'm not wanting to trick the kids. I'm wanting them to be successful. I'm not trying to trick them. I'm wanting them to be successful. And I'm going to go ahead and even spell out the word hour. So 60 minutes equals 1 hour. Well, then what is it that I'm wanting to do here? I'm wanting to turn one of these into 60 minutes. Now, if this is a new assignment, this is a new thing for the kids to do, I think I would just scoot it up gradually. So I'm looking at the 45 minutes. 45 is my larger number. I am more comfortable with adding on 5 to this, okay, to adding on 5 to this, and I'm getting 50. So that's pretty darn comfortable. Now I got the 50. I'm going to drag this 20 down. And so my answer, now my math problem is 20 plus 50. My goal is to get it to 60, right? I can split 20 easily. I know that that 50 now is just 10 away. It's just 10 away. And so I feel so much more comfortable saying, aha, 50 plus 10, there's my 60. There's my 60, which means that is 1 hour. And how many minutes do I have left over? 10 minutes. And so 25 minutes plus 45 minutes equals 1 hour and 10 minutes. I would definitely be using the Judy clocks, the clock that's on the wall in your classroom, to be talking about how many minutes away am I to making an hour. And so the kids are going to gradually see, oh, that was 15 minutes away. That's right, that was 15 minutes away. So see this 5 and see this 10? How many minutes away was it? 15. What's 10 plus 5? 15. And so we actually added 15 minutes on to 25. And we took 15 minutes off of, 15 minutes onto the 45. And we took 15 minutes off of the 25. And so we just are going to inch it up for the kids. Let's do another one. Another conversion that we do in 3rd grade, 4th grade, and on through life is with measurement. And so how about if we have 7 inches plus 9 inches, and you can go ahead and predict, you're right, we want our answer to be in feet and inches. So what do I need to do? Hey kids, how many inches are in a foot? And hopefully you've got some 1-foot rulers out and about, you know, near your kids. Let's take a look at that. How many inches equals 1 foot? That's where the metric system makes sense. It's in tens and hundreds. It's in the base 10. All right, so 12 inches is equal to 1, and I'm going to go ahead and spell it out. 1 foot, okay? Get that T to cross there. And so we need to boost one of these up to 12 inches. Well, the kids have gotten really, really, really good at boosting things up to 10. So since we're converting, I think I'm going to inch this up. I know, pretty good joke there, right? Inch this up. All right, I'm here all week. All right, so that 9 is 1 away from being a 10. So how about if I do this first? Now we're to 10. All right, so I need to move that 10 up to a what? 12. Oh, okay. I know what I could do. I just need 2 more. And so 6 is the same thing as 2 and 4. So take a look right here. And 10 plus 2 equals what? Yeah, that equals 12. So that's the exact same thing as saying 1 foot, right? And how many inches do I have left over? I have 4 inches left over. And so we just inched it up to help the kids see 7 inches plus 9 inches equals 1 foot and 4 inches. Now, some of your kids may say, oh, wait a minute, I got it. So we could have just added on to it 3 inches to start with, right? We could have just said to start with, I need to add on 3 inches. That would have 4 inches left over because a number bond for 7 is 3 and 4. I remember how we did that back in 1st grade, all right? And so that's another way that the kids can see that. All right, so that's with conversions. Well, let's boogie on up to, and let's start talking now about subtraction. Dun, dun, dun. Well, wait a minute. Wait a minute. Before I jump to subtraction, let's go ahead and go to fourth grade. I'm sorry, I totally skipped over fractions. So what if we have 4/5 plus 4/5? Well, we all know that that's 8/5, right? And if it's 8/5, now we have to convert it. Well, what if there's another way? All right, so let's go with another way. We know that what we can do here is we can turn that 4/5 into a whole number. Which one? I don't care. Let's do the one on the left. Let's turn it into a larger number. And so I could do 1/5, and then of course that would be 3/5 left over. Is everybody good? And so 4/5 plus 1/5 equals 1 whole. And so there's my 1 whole. And what's left over? 3/5. And so I just totally wiped out that middle problem, if you will, of having to teach where the numerator is larger than the denominator, so a mixed fraction. And so this totally makes sense to the kids because they've been doing number bonds since kindergarten. All right, so we totally took out that middleman of turning this into 8/5 and then having to convert 8/5 into 1 3/5. They're not there yet. Will I teach that? Oh, you bet I will. But initially I'm going to teach this so the kids can see what the answer is. All right, and so now let's do this. Let's clear that. And let's do a whole number. How about 7 2/3? And let's add on 2/3 more. Well, that would equal 7 4/3, but 4/3 is a mixed fraction. And so let's just take a look at this, and we're wanting to turn, now take a look, we're going to leave the 7 alone, all right? And so I need to take this 2/3 and turn it into a whole number. And so how much more do I need to put on there? Well, I could do 1/3 and 1/3. So now I'm going to take a look at this. All right, so 2/3 plus 1/3 equals 3/3. And 3/3 is the exact same thing as meaning I ate the whole thing. It's the exact same thing as a 1. All right, and so now I can look at this and go, well, 7 plus 1, that's 8. And what do I have left over? I have 1/3 left over. The kids love doing these, they really do. And by the time they come to you in the 4th grade, they've had number bonds, all right? So that's exciting. You're not having to totally, like the first year that we taught Eureka math, oh my goodness, I was teaching 4th grade. I was having to teach myself number bonds, let alone teach the class number bonds. So, but the kids, they get this. This makes sense to them, okay? All right. Let's go ahead and take that out. We're going to move on up now to subtraction and how we do subtraction with the number bonds. When I teach subtraction to the littles, I use those snap together cubes, and gosh, I wish I had them here at home. Just imagine, if you will, Legos, and you snap together Legos. All right, so I'm going to pretend here that I have snapped together my Legos, and I have 10 of them right here. All right, let's see if I can do it. 1, 2, 3, 4, 5, 6, there's 7, 8, 9, and 10. Okay, so I've snapped together 10 Legos. I like to do, it doesn't matter if you have them going vertical or if you have them going horizontal. It doesn't matter. Now, I would say to the kids, all right, now get for me a different color of your snap together blocks, and I want you to get for me just 2 of them. And so 1, 2. And when they represent ones, I generally have the kids not snap them together, okay? And so how many Lego blocks here do I have all together, or the linking cubes? Right now we're gonna go with Legos, okay? How many Legos do I have here all together? And of course, somebody's gonna holler out, you have 12. Yes, I do. I have 12 of them all together. All right, what if I came over to you and I said, hey, would you give me 9 of those? Now, I want you to not be a college graduate. I don't want you to be a teacher. I want you to be a little 5-year-old kindergarten child right now, okay? Please don't pick your nose though. I want you to be a little kindergarten child. I want you to be 5 years old. What do you think a little 5-year-old kindergartner would do if I said, hey, would you hand me 9 of your blocks? All right, now they have been working, or this could be a first grader, they have been working with making 10. And so to a little child, the easiest way to do it, I'm just going to cross them off to represent that, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Okay, now they would actually snap them off and scoot them over. Is everybody good? So what do I have left over? And so the kids would go, you have that many left over. Well, fantastic. How many do I have left over? Well, I have 1 red and I have 2 blues. I have 3 Lego blocks left over. Excellent job. But what was my math problem? Does anybody remember my math problem? My math problem was 12 minus 9, and that equals 3. That's how I start subtraction. This is the Eureka model for teaching subtraction. It is much more comfortable for a child to take from that rod of 10 and take the 9 off. It is very comfortable for them. And so what they looked at was, all right, 9 is in the 1's place value. They don't realize they did this, okay? 9 is in the 1's place value. So they're going to look at the 10's place value, all right? So they're going to come over here and turn this into a 10. And what the kids, whoops, excuse me, what the kids just did was that 10 minus 9 equals 1. Excellent, excellent. And so this is what they're doing mentally. And we never touched that 2. And so now we're going to combine the 2 and the 1. And I'm going to get 3. So I actually did a subtraction problem, turned it into an addition problem. All right, pretty interesting, isn't it? When you see it written out like that. And so what we've just taught the kids is this, that 12 minus 9, if you have 2, you can't take 9 away. And so what do you need to add to it? You need to add 10 to it. All right, you need to add 10 to it. Well, how do I add 10 to it? You're gonna go next door, cross off the 1. It's now a 0. I'm gonna add a 10 to it. So now what is 12 minus 9? Well, that equals 3. You just taught the kids what that borrowing represents. That borrowing represents a 10. Isn't that interesting? All right. I think it's a very cool method. Now, of course, would I teach all of that at once? Oh, heavens, no. No way. I would not do that. All right, now let's move this on up. Let's now take it to what is 32 minus 9. Okay, I want you to help me with this. I hope you're writing this down as we go. All right, so 32 minus 9. I'm looking at that 9. That 9 is in the 1's place value. So therefore, I need to take away from the 10's place value. I need to take it away from 10. So I'm going to come over here, and I'm going to turn this into a 10. Well, 32, and if I take 10 from it, that means I have 22 left over. And the kids have become excellent at doing this by now, all right? And so now I'm going to change my color here. So this is just an oh so simple math problem for kids. They're like, oh, that is so simple. That's just 1. That's right. What am I going to do with this 22? All right, so I'm going to bring this 22 down here, add it on to the 1, and my answer is 23. Isn't that interesting? All right, so I know you're like, gee, Mrs. Kimsey, you are really easily entertained. No, let's make it, it's going to make some sense here. So let's take a look at this. If we have 2, can we take 9 away? No, of course not. What do we need to do? We need to go borrow a 10. We need to take it from a 10. All right. Dun, da, da. All right, so now 12 minus 9, that equals 3. And 2 minus nothing equals 2. And so it helps the kids to see that 10. What did we do? We made a 10. Okie doke. All right, let's clear this. And we're going to try another one. This time it's going to be 50 minus 6. All right, and so that 6 is in what place value? It's in the ones place value, right? And so what do we need to take it away from? You always go to the next place value. We need to take it away from a 10. Exactly, and the kids are like, oh, that's easy. With a 50, that would be 10 and 40, because 40 plus 10, yep, got it, Mrs. Kimsey. All right, and so we understand number bonds very, very well at this point. That's 4, excellent. Bring down the 40. All right, and so 40 plus 4, my answer is 44. Again, I can come over here and say, all right, so 50 minus 6. If I have 0, I can't take 6 away from it. I need to go borrow a 10. I need to go borrow a 10. Remember that math problem? All right, so 10 minus 6, that's 4. Drop down the 4. We get the same thing. It's explaining, it's making it more logical of, oh, I see what we're doing now. All right, so now let's move on up to 3rd grade. And in 3rd grade, the kids are going to get 341 minus 60. All right, 60 is in, the 6 is in the tens place value. So we have to take it to the next level. I need to take it away from the hundreds place value. All right, so the kids love doing these. Oh, I know what that would be. That would be 241 and it would be 100. You're right. I always have the kids circle the math sign. Do you have to? No, there's no rule on that. I just do it to help them remember. You're going to take 100 down minus 60. And if I take 100 minus 60, I have 40. Did we ever touch this 241? No, we didn't. And so we need to add it on. 241 plus 40, my answer is 281. So again, we're helping the kids with mental math. We're helping the kids have some number sense. So when they do subtraction, their answer will make some sense. All right, and then I'm going to move it to, whoops. I'm going to move it to 341 minus 60. We're going to help it make some sense. Let me do this in a different color. 1 minus 0, of course, is 1. If I have 4, can I take 6 away? No. What place value am I going to go to? I'm going to the 100. Oh, whoa, what did we go to? We went to the hundreds place value. So I'm going to borrow from it how much? Not 1, but 100. Does that make sense now? And so we borrowed from it 100. And so really, my friends, that's 140 minus 6, minus the 60. So 14 minus 6 is 8. And I didn't put down the 2, shame on me. And there's the 2 for the 281. Okie doke. All right. Let's do one more for grins. 236 minus 50. And what does that equal? All right, I'm going to give you a moment to do that. All right, hopefully you notice, okay, 50's in the tens place value, right? The 5's in the tens place value. I have 5 tens. That means I need to go borrow how much from next door? 100. And so I'm going to change this into 100 and 236. If I take 100 away, that's going to give me 136. Okay, here's my first step. And the kids are like, no problem, got it, that's 50. Awesome. What are you going to do with that 136? We're going to add it on, and that equals what? 186. Okie doke. All right. Now let's go ahead and move on up to 4th grade, and let's do fractions. So if I have 5 whole, and I'm going to take away from it 3/4. Now, it used to be that we had to teach the kids how to take that 5 and turn it into a fraction over 4. So we would have to teach them. Now it becomes 20 over 4. And they're like, what? All right, I'm mind blown. And so what we need to do on this one is we're going to look at this. And we're going to, a fraction represents part of something, not one whole. It's part of something. It is less than 1. So again, what's the next level up then? If 3/4 is less than 1, we're only going to take it away from 1. So I'm going to partition this out. So that means I only had to take it to 1. 1 is still a whole number. Oh, I know. That's the exact same thing as saying 4/4. You're right. It's the exact same thing as saying 4/4. So now 4/4 minus 3/4, that would give me 1/4. Excellent. What's over here that we've never touched? The 4 whole, okay? And so my answer is 4 whole and 1/4. The kids totally get this when you take it out like this. And it also helps instruct to them that a fraction is less than 1. You know, we've been taken away from the tens place value, the hundreds place value. Well, now we're taken away from the ones place value, and that's using fractions. Okay, so then while we're on it, let's just do one more. What if we had 7 1/5 and we wanted to take away from it 3/5? Okay, so 3/5 is less than 1. So I want to take that 3/5, I want to have 1 and take 3/5 away from it. So I'm going to turn this into a 1. So that means what's left over on the other side, well, it'd be 6 whole and the 1/5. We're not even talking to that 1/5 right now. We're not even talking to it. All right, so 1 minus 3/5. Well, 1 is the exact same thing as saying 5/5, okay? All right, so 5/5 minus 3/5, and that equals 2/5. Everybody good? I'm going to go for my next step here. I'm going to take this 6 1/5 that we never touched and add it on. So my answer is going to be 6. And the kids have gotten excellent at adding fractions at this point. You add the numerators, keep the same denominator. I have 6 3/5. I didn't have to do this to 35 plus 1 is 36. 36 minus 3 is 33/5. I didn't have to go through all of that process. And so this is a great way, it's a wonderful way that we try to teach to the kids. Again, some mental math. And this time we're doing it with fractions. All right. So that's number bonds. That's number bonds. I'm going to bring over here with me my cheat sheet, and we're going to get started now on tape diagrams. The reason I'm bringing the sheet over is we use tape diagrams for word problems. So I've got my word problems on here. All right. Number bonds is so important. We're just going to wrap up here for just a second. Those number bonds are so important. We're going to start them in preschool, in pre-kindergarten. We're going to go to kindergarten. We're using number bonds. We're using number bonds the whole way through elementary school. It is so important that we're always using them. I skipped over, like with multiplication, how about 7 times 5? You know what? I'm going to do 7 times 6. 7 times 6, all right? So the kids could look at this and go, oh, I don't know my 7s. Oh, I don't know my 6s. So we could turn this into an easier problem. How can I make this an easier problem? Well, I could look at the 7 and say, well, I know what 5 is. I know my 5s and I know my 2s. All right, so then what is 5 times 6? That's 30. Everybody knows that one. Super. And so then what's my next multiplication? It'd be 6 times 2 or 2 times 6. That's right. And everybody knows their 2s. 2 times 6 is, it's 12. Exactly. Now we could add this up and we have 42. Now, the majority of your kids will learn their multiplication facts, but you have a small majority of your kids who have this total brain block when it comes to certain factors, 7s, 6s, and 8s. A lot of kids have a mental brain block on. So we need to give them strategies on how can you solve that. And so this is a wonderful strategy right there. And so we use number bonds. Could you have taken the 6 and factored it to 5 and 1? Of course you could. Absolutely. All right. And so we need to have this strategy for our kids who struggle and who freak out on the 6s, the 7s, and the 8s. And believe me, there are a lot of them that do. This is a wonderful strategy. Okie doke. All right, now let's move to those tape diagrams. Tape diagrams, we start doing them in about 1st grade. And by the time they get to 4th and 5th grade, they become pretty automatic. What we teach with Eureka Math is that you read the math problem. And anytime you come to a period, you come to a complete stop, and you think to yourself, what could I draw to make this part of the story make some sense to me? And then what could I write? And so writing would be labels, writing would even be a number, okay? And so we read it, we draw it, we write it to help lead us to the answer, to help us get to the answer. And it should be very natural for the kids. We should do it every single time, not just every now and then when we're stuck, but every single day we have an application problem, which is a real world word problem. So here we go. This one's about 1st grade. All right, now remember, they're used to using a 10 frame. They're used to seeing a group of 5. They know that 5 plus 5 is 10. Okie doke? All right, so let's keep that in mind. So this is about a 1st grade math problem. 13 children are on the roller coaster. That's our first problem. That's our first sentence. 13 children are on the roller coaster. All right, so we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, let me explain to you what I did there. We're used to, the kids really understand a group of 5 plus 5 more is 10, and they know that 13, I cannot add on 5 more. And so basically all we did is kind of like the yellow, this is 6 plus 4. And so we're helping the kids see that this represents a group of 5. All right, so I'm going to put that on here. And so that's my reading and drawing. Now I need to write something. And this represents 13 children. I would not call it a C. I would help the kids with phonics and say, I'm just going to put CH to represent children. All right, so far, this is what we know in our story. 13 children are on the roller coaster. Yep, we have 13 and they are children. 3 adults are on the roller coaster. 3 adults. I'm going to change color. I'm a KU person. All right, 1, 2, 3. I'm going to add them on. They get their own car. All right, this represents 3 adults. How many people are on the roller coaster? By reading this, drawing this, writing this, so many of your kids right off the bat can say, well, that's 16. That's 16 people altogether. I'm just going to put 16P. 16 people altogether. Really? How did you do that? That's outstanding. They were able to count on. Remember in 1st grade, we talk about counting on. And by having this picture, they were able to totally see, oh, and especially the child who's in the back going, 16? How did you get 16? All right, they know that that red represents children. They know that that blue represents adults. Again, have different colors to help with the representation. They understand that this represents 5, 10, 11, 12, 13, that counting on. So 13, 14, 15, 16. And so it's amazing how quickly they catch on to this. And so you're able to come over here and say, okay, this is what you just did. You just did a math problem. You just did 13 children plus 3 adults equals 16 people. Oh my goodness. And they get kind of excited about it. Now the thing is, you're not doing this alone up there on the whiteboard, okay, on your Promethean board or whatever. The kids need to be doing this on their slates. as well. And so that's very important that the kids are also doing this. All right, so now we're going to let's go to second grade here. All right, here we go. So don't forget, every single word problem, and this should go up on your Promethean board every single day. We're going to read this math problem, everybody. Now what are we going to do? We're going to draw a picture, and we're going to write. Well, what does writing mean? Writing can be a number, writing can be a label, but we're going to write something to help us get to the answer, okay, to help us get to the answer. You're going to read one sentence at a time. And my friends, the application problem is going to be up there on the Promethean board. It's going to be in their book. You need to read the math problem to the kids. This is about math. This is not about reading. And we need to take those words, that reading, out of making this a difficult problem for our children. We need to do the reading. So one sentence at a time. This time it is, an orange weighs 198 grams. Now, a lot of children don't know what a gram is. Quite honestly, a lot of adults don't know what grams are. One paper clip equals 1 gram. And so you knew that you were having this math problem today. You could have stopped by the office and got 2 boxes of paper clips. There are 100 paper clips in a box. And said to the kids, if an orange, and I'm even going to use the color orange, and I'm going to call it OR. Any reason why I just didn't call it O? We're doing math. What does that look like? A 0. It looks like a 0. And so I'm going to make sure that my children know that this stands for orange. And by using the color orange, that's going to help as well. So an orange weighs 198 grams. All right, guys, I have 200 paper clips here, and this represents 200 grams. I could take 2 paper clips out. Now I have 198 grams. This is what an orange weighs. That's giving the kids a really, really good idea of what an orange weighs. All right, I'm going to make a rectangle. It's a tape diagram, so it looks like a piece of tape. And this is 198 grams. Okay, now I like to put my label on the rectangle. Some people like to, draw up above here and put the 198. I like to put it inside the tape diagram. Either way is right, okay? All right, so my orange weighs 198 grams. Awesome. I'm even gonna put an equal sign. So that did a little bit of writing. Here comes my second sentence. A kiwi, oh my goodness, wait a minute. Stop the math problem. We need to talk about what is kiwi. And so many of your kids will not know what a kiwi is. Okay, so we're going to tell them that kiwis they're green and they're smaller, kind of fuzzy on the outside. You open it up on the inside, it has lots of black seeds in it. They're delicious. And so for kiwi, we're going to put a K. All right, we're going to make it green because kiwis are green. All right, so a kiwi weighs 85 grams less than the orange. And so what is the total weight of the fruit? Oh my goodness. All right, so we need to make the rectangles the same size, right? We're comparing the kiwi to the orange. What do we know? We know it's 85 grams less, but do we know how much the kiwi weighs? No. So I'm going to put a question mark here. I don't know what the kiwi weighs, but I do know that it weighs 85 grams less. And so I'm going to make this part over here 85 grams. So now I would talk to the kids, and if this is their application problem of the day, I think I would stop right here in helping to set them up for success and say, all right, how are we going to figure out how much the kiwi weighs? We know what the orange weighs. We know that the kiwi weighs 85 grams less. So am I doing addition or subtraction? And hopefully the kids are figuring out it. Oh, you're going to do subtraction. Fantastic. All right, would you two be partners? You two be partners, and so on. And so the kids are going to partner up, and now you're going to have them see if you can figure this out. Ready? Go. And you're just going to set the clock for however many minutes it says for the application problem. Generally, this is about 10 minutes. All right, and so then hopefully you're going to call them all back together. All right, guys, how did you do this? All right, so we took the 198 grams and we subtracted the 85 grams. Excellent, excellent. And so 8 minus 5 is 3. 9 minus 8 is 1. Excellent. 1, drop it down, and grams. And so now we know that the kiwi weighs 113 grams. Excellent. You didn't answer the question though. The question is, what is the total weight of the fruit? Oh, all right. So we know that the kiwi weighs 113 grams. All right. How am I going to figure out how much the fruit weighs all together? And so hopefully the kids are going to say, we're going to add up the 198 plus 113 equals, and I'm going to stop right there. You guys got the idea? But by having the tape diagram there, 198 represented the whole. That's the whole amount. So that's what we had to base the kiwi off of. But by having those on there, it helps them see the parts of the equation. Right, believe it or not, that was second grade, towards the end of second grade. All right, let's take a look here at third grade. We're going to move up to now multiplication. So here we go. Each of Maria's 4 friends has 3 markers. All right, let's stop right there. We're going to read this. Whoops, I am so sorry. We're going to read this. We're going to draw. We're going to write to help get us to the answer. So each of Maria's friends, and she has 4 friends, friend 1, 2, 3, 4. So she has 4 friends. We could name them. You have 4 kids in the classroom. Who wants to be Maria's friend? And you can name them, okay? And so they each have 3 markers. Okay, 1, 2, 3, to represent the 3 markers. 1, 2, 3, 1, 2, 3, 1, 2, 3. Excellent. How many markers do Maria's friends have in all? And so what we've just done right here is created the very beginning of multiplication where we have equal groups. We have 4 groups, we have 4 kids, and each one has the exact amount. So we've just created the first step. And so many of your kids are going to go, well, that's 3 plus 3 more, plus 3 more, plus 3 more. Again, another step to multiplication, repeated addition. They know that 3 plus 3 is 6, 3 plus 3 is 6, 6 plus 6 equals 12. And so there are 12 markers altogether. That is outstanding, everybody. Way to go. Let's move this into a tape diagram. And so we're going to have 4 equal units. And so we're going to use the word units. 4 equal units. And inside of each of those units, so we have 4 children, inside of each one, we're going to have our 3 markers, and we're going to arrange them the same way. Granted, my last one there did not turn out so hot, did it? There we go. Well, doggone it. There we go. We're going to arrange them the same way because what we're creating here is an array. And so that's the next level with multiplication. And so hopefully the kids, and they need to label this. All right, so this represents that we have 4 friends, and each friend has 3 markers, and we know that altogether they have 12 markers. Excellent. How did you just do that? Oh, and so they're going to see what they just did was put in a multiplication sign. That 4 friends times 3 markers equals 12 markers altogether. That's how we do it to learn multiplication. All right, so equal units. We have Morgan. Again, we're going to read it, we're going to draw it, we're going to write out something to help lead us to get to the answer. All right, so we have Morgan. Morgan is 23 years old, and this is a 4th grade math problem. So we have Morgan, and since this is a word problem, we're just going to go ahead and draw it out here. We're just going to become so accustomed to this. And she is 23 years old. So I'm going to put 23 YO for years old. So Morgan is 23 years old. That's what we know so far. Her grandfather is 4 times as old. And so of course the question, how old is grandpa? All right, so we'll do grandpa. So GP for grandpa, he's 4 times as old. And so the kids are going to go, okay, so that means I need to do 23, there's 1 time. 23, there's 2 times. 23, there's 3 times. And 23, there's 4 times. And so we have 4 equal units. He is 4 times as old. And so our math problem would be, we could do the repeated addition of 23 plus 23 plus 23. Good thing it wasn't times 12, right? Plus 23. We could do that, or the kids could learn, they can move that up to the next level and say, well, that would be 23 times 4. And again, this is where the kids are just learning multiplication. And so maybe what we could do is take this out to 20 and a 3, and our kids know that 20 times 4 equals 80, and 3 times 4, that equals 12, to find out that grandpa is 92 years young. Go grandpa. All right. And so that is a way that we do this. All right, my friends, number bonds are awesome. Inside of your Eureka math book, I'm going to go ahead and push stop share here. Inside your Eureka math, let me pull this up. Inside of Great Minds, the website for your Eureka math books. Let's say you're in the 4th grade. Let's do a multiplication unit. That would be right here's one. And we want to go down to any of these, and let's just do, let's see if I can find here. Go down to this one. There's a video for them. Please make sure you're watching the videos to help you better understand how do we turn an application problem, so the word problem, how do we turn it into a tape diagram? These Eureka videos will be oh so helpful. All right. So again, today what we did, we talked about number bonds and we talked about tape diagrams. I'm Diane Kimsey. I'm your math consulting teacher. Call me, text me, email me. I'll be there to help you. Thank you.